Okay, well, thank you very much for that. And hi, my name is Sai, and I work at a team at Apple. And I'm part of a team that maintain a collection of Swift open source packages focused mainly on server-side use cases. And today, I want to show you how you can get started by building an end-to-end example from scratch. And not just a hello world server. Today, in about 15 or so minutes, we're going to build a Linux proxy server for a well-known API, the ChatGPT API, and one that supports end-to-end streaming. And we'll build a macOS CLI client as well. So we're going to be moving very fast, and there's a lot of moving parts, but we've open sourced all the code that you'll see today, and I'll put a link up at the end so you can check it out after the session. And finally, we're going to be doing mostly live coding for the entirety of this talk, and we'll be calling a real third-party service and one that's backed by an LLM. So let's hope it's entertaining for all the right reasons. So before we get going, let's talk about the building blocks we'll use today. We'll be using Swift OpenAPI to generate a ChatGPT client for making the upstream calls to ChatGPT service. And we'll also use it to generate the proxy server with a tailored API. VS Code will be our editor for today, and we've installed the Swift and the OpenAPI extensions. We'll use dev containers to run the service on Linux. And because Swift OpenAPI clients and servers both have a pluggable transport layer, we'll be using Vapor and AsyncHTTPClient when on the Linux server, and we'll be using URLSession when making API calls from macOS. But before we start, why would you use a proxy in the first place? Why not just make the upstream calls directly from your client application? Well, there are a number of reasons you might want to consider this approach. First, you might not want to bake your credentials for the upstream service into your client application. Second, you might want to customize the prompt that's being used and maybe update it quite frequently. Third, you might want to be able to change the model that's being used, or maybe swap out the entire upstream service for something else. And finally, you might want to provide a more tailored experience for your users by transforming the requests and response before they're sent to the LLM. So the proxy we'll build today will take advantage of all of these benefits. So what's going to be our use case? Well, my teammates and I are sports fans, but when we attend live games, we're often very underwhelmed by the creativity of the chants that they sing. And they always go, "Let's go, team name," and that's just so boring. We can do way better than that. We want something that's creative and fun, something engaging, that contains specifics about a team we're watching and its players. Enter ChatGPT. So this is a tailored service that's backed by ChatGPT that can generate team-specific songs to sing at games. So let's take a look. This is the API that we're going to be using today. I'll show it you in curl first. It's an API from OpenAI, and it's the chat completions endpoint. This is the API that drives ChatGPT. We're using the latest ChatGPT model, and we're providing an API token as a header field. We are using streaming mode, using the stream parameter and the no buffer flag for curl, and we're just asking the LLM, "Hello, are you there?" If we run this, we get a pretty opaque stream of messages in a format called server-sent events. We'll come to that later. But how are we going to call this API from Swift and decode this stuff on the fly? Well, thankfully, OpenAI provide an OpenAPI document for their API on their official GitHub. An OpenAPI document is just a YAML file that describes in a structured way all of the operations that make up the API surface, including the chat completions endpoint. This is great because we're using code generation, and even though we're only using one operation for today's demo, it means we could easily extend the application with new functionality, like audio streaming or image generation. So I'm going to switch over to VS Code, where I've downloaded this OpenAPI document into essentially an empty Swift package. The VS Code OpenAPI plugin comes with Swagger UI as a great way of looking at an OpenAPI document. And if we find the chat completions API here and expand it, we can see the parameters it accepts. Here we can see it takes the messages that make up the prompt, the model, and here's the stream parameter. If we expand the documentation, it says if streaming is enabled, tokens will be sent as a data-only server-sent event stream as they become available, terminated by this data done payload. That's great. That's what we saw when we curled the API. So Swift OpenAPI can generate all the code we need to call this API. So I'm going to go over to the package manifest, and we're going to create a ChatGPT client. I'll start by adding the package dependencies that we're going to use. And then, because we're planning on using the ChatGPT client from a proxy server target later, which will have its own OpenAPI document, I'm going to generate the ChatGPT client into a dedicated target. This target depends on the OpenAPI Generator plugin, which will generate the client code, but it also depends on the runtime library. That provides the common types that's used by the generated code. This target will need a source directory, which I'll create now. And I'll drag in the OpenAPI document. The plugin also requires a config file, which I'll create. Here, we're instructing the plugin to generate the client code, and we're also filtering the API to just the operations we care about, because this will speed up the build, especially for a large API surface. And because we need to provide that API token as a header field, we're also going to create a middleware. This middleware intercepts every HTTP request and response, and for all outgoing requests, it appends a header field, which it takes the value from an environment variable. We'll use this to inject our API token. So now we have everything we need to start building a CLI client for ChatGPT. So I'll start by importing the modules we're going to use, and then I'll create a client. Here you can see we're using the URL for the real upstream service, and we're creating the client using the URLSession OpenAPI transport. We're also using that middleware that we just created and taking the token from an environment variable. Next, we can prepare the prompt. Here, the system prompt instructs the LLM to create fun and witty chants for baseball teams, and it determines which team from a command line argument. Next, I'll print a placeholder to the console, and I'll disable buffering on standard output. It's important for streaming so that when we print those partial responses, we'll see them immediately. Next, we can make the request. Now, the generated client contains one method for each of the API operations in the OpenAPI document, and the parameters they accept are generated types, so it's type safe. Here we provide the messages that make up the prompt, the model, which is a generated enum value. We enable streaming, and we set this other parameter, temperature, to 0 because, well, we don't want any hot takes. This response value is also a generated enum, which allows you to exhaustively switch over all the things that the server could that is documented the server could return. But if you're expecting something specific, you can use a type-safe throwing API to extract the body of an expected content type. Here we extract the text event stream content type, which is the content type for server-sent events. And the body is an async sequence of bytes, so there's no buffering in the client. The OpenAPI runtime library provides a bunch of helper functions that deal with the common streaming content types, including server-sent events. So with this one line, we can decode that async sequence of bytes into an async sequence of typed values. Now all that's left is for us to iterate over the async sequence and print those partial messages as they arrive. So that's all the code we needed to write to make a type-safe streaming API call to ChatGPT. All the serialization of the various types, as well as the logic for doing streaming HTTP requests and response, is all handled by the generated code and the runtime library. Not only does this make it faster and simpler to get started, but it also removes a whole class of bugs if I were to keep re-implementing that in every single project. So let's see how it works. So maybe you don't even know the team you're watching and you're trying to work it out, but because this is an LLM, we can use natural language to identify the team, and we'll ask for a chant for the team with the bird logo. And after the project's built and the generator is run, what did I do wrong? Hilarious. Okay, I know what I've done wrong. So in the package, I didn't actually add the ChatGPT client as a dependency of my CLI, which I'll do now, along with the URL session transport that we're using. Gotta love those live demos. So hopefully now we should get a chant streamed to us for, okay, the Orioles. Great. So let's try something else. Let's ask for a team for a specific player. Let's say the team Juan Soto plays for. And this time we get, okay, so we got a Padres chant. And for any baseball fans in the audience, they'll know that that is not the correct team. Juan Soto doesn't play for the Padres, at least not anymore. He's moved teams a couple of times and is now at the Mets. So what's happened? Well, the model has done the best it can with the data it was trained on, but it doesn't have access to the latest team rosters. Well, that's okay. Because we control the system prompt, we can provide more context when we make the request. So I'm going to go and create a new file, creatively named players.txt, which contains a list of all the players and the teams that they play for. Then I'm going to provide the contents of that file as part of the system prompt when making the request. Now, if I make the same request for Juan Soto, hopefully we'll get what we expect. Okay, we get a Mets chant. Great. So let's check in with where we are. We've built a type-safe streaming API client for ChatGPT, but we've reached a point where we'd like to be able to abstract the system prompt away and maybe update it frequently. So we're going to move this logic now into a proxy server. So I'll start by creating a new target for the proxy server. This target also depends on OpenAPI Generator, so it's going to need an OpenAPI document and a config file. So I'll create the target source directory here. And the OpenAPI document. So we want a tailored, simplified API, and this is it. Best way to show you will be in the Swagger UI. Here we have just one endpoint, a chant endpoint. It takes only the user input, no need to select the model or any of those other parameters, and it returns a simplified JSON streaming structure known as JSON Lines. So I'll create the config file for the plugin as well. So this time, instead of generating the client code, we're going to generate the server stubs. So now we've configured the plugin, we can implement the server. So create the main.swift, import the modules that we need, and I'm going to define a type that conforms to a generated Swift protocol. It's called API protocol. This protocol defines one method requirement for every operation defined in the OpenAPI document. And those input and output types, remember, they're generated data model types. So all the parsing and validation of the request is handled for you, as well as the serialization of the output type. For now, it just throws an error, but that's enough for us to bootstrap the server, which we do by creating a vanilla Vapor application, which is a HTTP web framework in Swift, and using this generated function called register handlers. This will set up all the routing table in the HTTP server to route any incoming requests for our API to our handler functions above. So with the server scaffolding in place, we can now fill in the business logic for this handler. I'll start by extracting the body of the response and returning an appropriate response if it's not the expected content type. And then I'm going to copy all of the code from our client CLI that runs on macOS. And I'm going to paste it into the body of our server handler. Now, this code was designed to run on macOS originally, so we need to make some changes because it's going to be running in a Linux server in that dev container. So I'm going to start by replacing the URL session transport with the AsyncHTTPClient transport, which is the preferred transport on Linux. Now, note, this is the same client We've just created it with a different HTTP library. We're also going to, instead of taking the input from a command line, we're going to take that from the request body and delete anywhere where we were printing to the console. That doesn't make sense for the server. So that's the placeholder and where we were printing those partial messages. Okay, so at this point, we have an async sequence of ChatGPT payload, full of all the ChatGPT fields, but we don't want that. We want to provide a simplified response for our tailored API. So we need to map this using an async map to another async sequence. We use this compact map here, which transforms the async sequence of ChatGPT payload into an async sequence of proxy payload, extracting just the field that we care about. And now all we need to do is take that async sequence, encode it as JSON lines, and return it as the body of our OK response from the handler. Okay, I'm going to build and run this server. And it'll take a few seconds. But when the server starts, it'll be listening on localhost, port 8080, which will be forwarded to that Linux dev container. Okay, the server's running. And yep, the pop-up says that port forwarding is enabled. So if we head back to our terminal, we can hit this service using curl. Again, with no buffer, we're hitting the localhost service with the chant endpoint. And we're asking for the team Juan Soto plays for. And we get this stream of simplified JSON line responses that are being transformed on the fly from the ChatGPT payloads. Okay, so let's check in again with where we are. We've now built a Linux proxy server with a tailored API surface that can stream responses from the upstream service and with no buffering, transform them into a simplified API surface for our proxy users. And we still have a couple of minutes left. So I'm going to go back and update that CLI client to use the proxy server instead of calling ChatGPT directly. So let's, because the proxy server is defined using OpenAPI, we get to use Swift OpenAPI again for the third time. This time, we're going to generate a proxy client. So I'll start by taking the OpenAPI document and the config file from the proxy server. I'm going to copy those into the client CLI directory. I'm going to update the config file to generate the client code instead of the server stubs. And then I'm going to update the target in the package manifest. It no longer depends on the ChatGPT client directly, because it's going to call the proxy. And it's going to use the plugin like the other targets, this time to generate a proxy client. So now we can update the code for the CLI. We'll start by removing that import of ChatGPT, and we'll replace ChatGPT.client with just client. So this is the client that's local to this target. In this case, it's the proxy client. We're going to change the URL to be our localhost URL, and we don't need this authentication middleware anymore because that's being handled by the proxy. And we also don't need to define the system prompt because that's being handled by the proxy too. We can remove all the code to do with preparing the request, as well as making the request and printing the response. Okay, so this is the entirety of the code on screen now for the client CLI. So now we'll replace that code with this updated code to call the create chant endpoint of our proxy server, providing just the user input and iterating over a much simplified JSON Lines async sequence and printing the messages. So if we go back to our terminal one more time, we should be able to run the CLI and ask for the team Juan Soto plays for, and we should continue to get that Mets chant because the proxy server is handling the system prompt with the updated rosters, and it's all streamed end to end. If we go back to VS Code, we can see that the Vapor server handled this chant request here. Okay, so we've covered a lot, so let me recap. We've implemented a proxy server with a tailored API surface that handles streaming from an upstream service and transforms it into a tailored API surface for our downstreams. And we didn't write a single line of networking code thanks to Swift OpenAPI. In just over 15 or so minutes, we've used 3 different transports on 2 different platforms. Thank you so much for your attention today. If you have any questions about this demo, the Swift OpenAPI project or Swift on Server in general, you can come and find me in the office hours. If you just want to meet me and say hi, I would love to meet you too. Thank you so much.
再三素晴らしい